In this lecture, we are going to talk about three different classes of organic compounds. They are the alkyl halides, alcohols, and amines. So let's recap from the what we talked about the functional group of these three different classes from the first lecture. So if you still remember that we talked about different functional group of the different classes of organic compound, and we said that alcohols, the functional group is an OH. So simply you have an alkyl group, which is an R. This R here is the alkyl group, and the OH is the functional group. The importance of the functional group is that this is the group that is responsible for the physical and chemical properties of this series of compounds. The simplest example of alcohols is going to be methyl alcohol, which is a methyl group attached to an OH. The second class is the alkyl halides, and alkyl halides, from the name, there are an alkyl group attached to a halide. Halides are fluoride, chloride, bromide, and iodide. So the X here refers to one of these four halides. So any of these will be an alkyl halide. The simplest example again is the methyl chloride. So methyl chloride has a methyl group and a chloride attached to a chloride. The third class of compounds we are covering this lecture is amines, and amines are the simplest way to represent its functional group is the presence of nitrogen. Okay, so and based on what type of substituents are there on the nitrogen, it's going to be either primary amine, secondary amine, or tertiary amine. We will talk more about the structure of all of these classes and in order to understand more about the primary, secondary, and tertiary of the amines. So let's talk about the structure of alkyl halides. So alkyl halides, we have an alkyl group, as we said, and we have a halogen or halide attached to the alkyl group. Um, the simplest we can talk about was methyl chloride, as we said. So as we know that this carbon is an sp3 carbon because this is an alkyl group, and there is an overlap between the sp3 orbital of the methyl group of the carbon with the chloride. Um, we can categorize or we can classify alkyl halides into three types. We have primary halides, primary alkyl halides. We give it the symbol I1, and secondary alkyl halides, and tertiary alkyl halides. So the difference here between primary, secondary, and tertiary is when we look at the carbon attached to the halide. So if this carbon is attached to two hydrogen and only one carbon or another alkyl group, then it's going to be called primary. So primary alkyl halide is simply when the carbon attached to the halide has a minimum of two hydrogens. Secondary alkyl halides, when this carbon attached to the halide has only one hydrogen, but has two different R groups. The R here means any group that starts with carbon, so it can be alkyl, aryl, or anything. Tertiary alkyl halides now, so basically the carbon directly attached to the halide does not bond to any hydrogens, but it has three different, it could be different or the same, but it's attached to three other groups. They can be alkyl or they can be aryl. Aryl here we mean the aromatic system, but let's focus more on the alkyl group because most of what we are talking about here in this course is about alkyl groups, not aryl one or not the aromatic system. So to summarize, alkyl halide, the carbon is sp3 hybridized carbon, and we have primary, secondary, and tertiary. Alcohol has the exact same structure like alkyl halides and still have the same three primary, secondary, and tertiary based on how many hydrogens or how many other alkyl group are attached to the carbon, which is attached to the hydroxyl group, which is the functional group. So first of all, the hybridization state. So the carbon is sp3 sp3, the carbon, and then the oxygen. So what is the hybridization state of the oxygen? The oxygen is also an sp3 hybridized oxygen. So we know that oxygen has total of 8 electrons, and the distribution of electrons is 1 is 2, 2 is 2, then 2 bx, 2 by, and 2 bz. So there is 1, 2, 1, and 1. So, so these four orbitals are mixed together to give you a new sp4 sp3 hybridized orbitals, and all of them will be called sp3 orbitals. So sp3 three orbitals, 1, 2, 3, and 4 sp3 orbitals. Two of them will only have 1 electron, and the other two each will have 2 electrons. So only the sp3 orbitals that has 1 electron will be able to take part in bonding. The other two will have 2 lone pairs of electrons. So they are not taking part in any bond formation. Again, the arrangement of these orbitals is going to be tetrahedral, exactly the same like the sp3 orbital arrangement of the carbon, but now two of these orbitals will only have lone pair of electrons. It's not going to be bonds. And the angle between the hydrogen, oxygen, and the carbon is 108.9 degree, almost 109 degree. For water, water is the simplest alcohol we can talk about because it doesn't have any carbon. So it's the angle here is 104.5. So it's the angle here will depend on the molecule try to get to the atoms or the bond as far away from each other to inhibit the repulsion between the electrons in the bond. So these are the this is the hybridization state of the carbon and oxygen in alcohols. Again, in the same way, we have primary alcohols, secondary alcohols, and tertiary alcohols, depending on if the OH group is attached to carbon that is primary, or carbon that is secondary, or carbon that is tertiary. So this is the three classes of alcohols. Amines have a bit of a different story. Again, the hybridization state, we will focus here on the hybridization of the nitrogen. The nitrogen is exactly the same like the oxygen. It has 7 electrons now. Oxygen had 8. It has 7 electrons in total. Again, there will be the 2b with, the 2s with the 3 2b will be hybridized together to get you an sp3 hybridized nitrogen, hybridized orbitals in the nitrogen. And now three of the sp3 hybridized orbital will only have 1 electron, and so 1, 1, 1. The last one is going to have 2 electrons. So now the orbital that has 2 electrons will not take part in bond formation. So any nitrogen will be able to make only 3 bonds with an extra orbital that has 2 electrons. This is called the lone pair of electrons. And the lone pair of electrons plays an important role in the physicochemical properties of amines. So again, the nitrogen in the amines is an sp3 hybridized nitrogen. So now as we talked about, amines, we said they can be primary amines, secondary amine, and tertiary amines. So now the primary, secondary, and tertiary amines does not depend on the carbon attached to the nitrogen, but it depends on how many alkyl group or how many hydrogen are attached to the nitrogen. So we now focus on the nitrogen itself. So primary amines basically has only one alkyl group and it has 2 hydrogens. So this is the primary amines. Secondary amines has 2 alkyl groups and 1 hydrogen. Tertiary amines is the one that has 3 alkyl groups attached to the nitrogen. All of these also still have the lone pair of electrons. And remember, if it's an sp3 hybridized orbital, then the shape is going to be tetrahedral. So again, it's tetrahedral, but the orbital, the fourth orbital that has the lone pair of electron is part of the tetrahedral as well.